All right, welcome. We're here to tackle one of the big ones, meteorology for your commercial pilot license exam. Let's break down exactly what you need to know.
So what we're doing here is basically distilling all the must-know concepts from Bob Tate's CPL Meteorology Guide. This is the stuff that's not just going to get you through the exam, but will actually make you a safer, smarter pilot.
Look, if you're feeling a bit swamped by all the med prep, trust me, you're in good company. It's a massive topic. So what we're going to do is cut through the noise. We'll simplify the really complex stuff and focus on what you absolutely have to know, starting with the big picture and bringing it all the way down to what it means for you, right there in the cockpit.
Okay, so here's our flight plan. First, we'll get into how our atmosphere works. Then we'll look at clouds and stability, how weather actually happens. After that, the really important bit, hazardous weather. And finally, we'll get hands-on with decoding the weather reports you'll be looking at on every single flight.
All right, let's get right into it. First things first, we need to understand the massive, invisible engine that drives pretty much all the weather you'll ever fly through.
So the first thing to get your head around is that the atmosphere isn't just one big blob of air. It's actually layered, kind of like a cake. And for us pilots, we live in that bottom layer, the troposphere. This is where basically all the weather happens. And right on top of it, you've got the tropopause, which acts like a lid or a ceiling, keeping most of that weather contained below. So where does all this weather come from? Well, it all starts with the sun. Think of the sun just hammering the equator with heat. All that hot air has to go somewhere, right? So it rises up, spreads out towards the poles, cools down, sinks, and then flows back. This creates this incredible global circulation system, like a giant conveyor belt for the planet, moving heat around. And that is the root cause of our big high and low pressure systems and the winds we have to deal with.
Okay, now you'd think wind would just blow in a straight line from high pressure to low pressure. Simple, right? But it doesn't. Because our planet is spinning, this spin creates something called the Coriolis effect. And the key takeaway for you as a pilot in the Southern Hemisphere is that it bends the wind to the left. That's it. That's why wind spirals around those highs and lows on your weather chart, and it's the very reason you're constantly making corrections for drift.
All right, so we've got these huge, invisible forces moving air around the globe. But how does that turn into the weather we can actually see? The stuff we have to fly in, around, or through? Well, it all boils down to two things, clouds and stability. And this slide is perfect for showing the two main families of clouds. On the left, you've got your cumulus clouds. Just think heaps or puffy cotton balls. These guys form when pockets of warm air shoot upwards. They usually mean the air is unstable, so you can expect bumps and maybe some showers. Then on the right, you have stratus clouds. Think layers. These are your flat, gray, boring sheets of cloud. They form when a big layer of air is lifted gently, and they usually mean stable air, smoother flying, and maybe some drizzle. And this gets us to probably the single most important concept in day-to-day flying, stability. It's super simple, really. It's just about whether the air wants to rise or stay put. Unstable air, it wants to rise. It's like a hot air balloon. It's warmer than the air around it, so up it goes, creating those bumpy rides and puffy cumulus clouds. Stable air is the opposite. It's lazy. It wants to stay right where it is. If you force it up, it'll try to sink back down. That's what gives you smooth conditions and those flat stratus clouds. Seriously, for a pilot, knowing the stability tells you everything about the ride you're in for. Okay, this is where we get to the really critical stuff. Forget just bumpy or smooth for a second. Let's talk about the kind of weather that can genuinely ruin your day, the stuff that poses a direct threat to you and your aircraft. The best way to think about a thunderstorm is like a recipe. You need 3 specific ingredients. If you're missing even one, it's a no-go. First, you need that unstable air we just talked about, air that wants to rocket upwards. Second, you need a ton of moisture, high humidity, to build those massive clouds. And third, you need a trigger, something to get the whole process started, like the sun heating the ground or a front pushing the air up. You have to have all 3, no exceptions.
And these storms have a distinct life cycle. It all starts with the developing stage, where it's all updrafts. All the air is just rushing upwards. Then comes the mature stage. This is the bad boy. This is when rain starts to fall, and that falling rain drags air down with it, creating these violent downdrafts. So now you have this massive conflict inside the cloud, air going up and air coming down. That's what creates the really severe turbulence, hail, the whole works. Finally, you get the dissipating stage. The updrafts die, the downdrafts take over, and the storm basically rains itself out and dies. Knowing what stage a storm is in is absolutely key to staying away from it.
Okay, let's talk about a really sneaky hazard, airframe icing.
This is some weird physics. You fly into a cloud where the water droplets are supercooled, meaning they're still liquid even though the temperature is below freezing. The second those droplets hit your cold airplane, bam, they freeze instantly. This completely messes up the shape of your wing, killing your lift, and it also adds an incredible amount of weight. And you've got to watch out for clear ice in particular. It can build up so fast you won't believe it, and it's almost impossible to see.
And then there's the microburst. This is one of a pilot's worst nightmares, especially on approach. Imagine a huge, invisible column of air just plummeting out of a thunderstorm. It hits the ground and spreads out violently. If you fly into one, well, first you get a sudden headwind, so your airspeed jumps. Then you hit the downdraft, pushing you toward the ground. And then, instantly, you're in a massive tailwind, and your airspeed just vanishes. It's a recipe for disaster and one of the biggest dangers you can face close to the ground.
So that's a lot of theory about what's happening up in the sky. But how do we actually know what's going on before we take off? How do we get this information? Well, we have to learn to speak the language of aviation weather.
Okay, at first glance, this just looks like a bunch of gibberish, right? But this is actually a METAR, a meteorological aerodrome report. Think of it as a super condensed snapshot of the weather at an airport right now. To the untrained eye, it's nonsense. But to a pilot, this little line of code tells you everything you need to know. Wind, visibility, clouds, pressure, the whole lot. So let's crack the code.
See? Once you know what to look for, it's pretty straightforward. Each little chunk means something specific. YBBN, that's Brisbane Airport. The time, 0300 Zulu. The wind, it's from 060 degrees at 10 knots. Visibility is 9999, which means it's great, 10K or more. We've got some light rain showers, some scattered clouds at 2,500 feet. You get the idea. Learning to read this fluently isn't just a good idea, it's an absolutely essential, non-negotiable skill. This is your lifeblood of weather info.
So there you have it, a whirlwind tour of CPL Met. But listen, the goal here isn't just to pass an exam. It's about building a real understanding, a real respect for the power of the atmosphere. It's about being able to make smart, safe calls every time you fly. The sky's always giving you signs, always telling you what it's up to. This knowledge, this is how you learn its language.